how we can actually calculate pH. So you've already explored how we measure pH using indicators and pH meters, but now we're going to talk through how we can actually calculate it if we know the concentration of acids or base in solution. So to calculate pH, I have this little roadmap here, and you should get a paper copy of this. It should be printed out. And once again, just like you had for your mole map, which you attach to the back of your periodic table, I would suggest putting this on the back of your periodic table. You can use it on any quiz or a test because, once again, I just don't believe in you memorizing formulas. I don't think it's useful, particularly for a high school chemistry class. And so how we're going to use this is whatever you start with. So let's say we start with a concentration of hydrogen ions or hydronium ions, and we want to know what the concentration of hydroxide ions is. Okay, we're going to follow the arrow that leads us from where we're starting to where we're ending, and we're going to use what it shows here. So this says that a hydroxide ion concentration should be equal to 1 times 10 to the negative 14th divided by our either hydrogen concentration or a hydronium concentration. Okay, let's say we have this concentration, but we want to know pH. Okay, that tells us, okay, we need to go and take the negative log, okay, you just push the log button on your calculator, of your concentration that you have, hit enter, and that's your pH. Okay, so we're going to use this roadmap. You're going to want to reference it, so please make sure that you have it ready to go. It should be also in your notes. Okay, so our sample problem 1. An ordinary household ammonia cleaner is an aqueous solution of ammonia gas with a hydroxide ion concentration of 4.0 times 10 to the negative third molar. They want us to calculate the pOH and the pH of a typical cleaner at 298 K. So this is just saying, hey, this is at room temperature. We don't need to really worry about that too terribly much. I didn't want to totally exit that. I just wanted to make that smaller so that way I could get into my little writing thing. Okay, so the easiest thing to do, okay, they gave us the hydroxide concentration, okay, and they said that that was 4.0 times 10 to the negative third molar. Okay, now the easiest thing to find from there is pOH. So if you check that little roadmap, it tells you that pOH is equal to the negative log of your concentration of hydroxide ions. Okay, this P means take the negative log of whatever follows it. Okay, so what we're going to do, we want to take the negative log of 4e negative 3. So remember back in our stoichiometry unit, I mentioned that it's nicer, your calculator likes it a little bit better when you use that capital E, which is second comma on any Texas Instrument thing. Your calculator is a little bit better at understanding that than when you type in times 10 to whatever. So calculators are kind of dumb, so you gotta listen to it. So this ends up being 2.39. And now with pH and pOH, the significant figures are going to be the numbers after the decimal point. So since the concentration had 2 significant figures, that means we want to include 2 digits after the decimal point. Okay, to find pH, we're actually going to use the value that we found for pOH because that's much easier. Okay, we already know, actually, that shouldn't be 2.39 because if I actually rounded, that should be 2.40. That 9 actually rounds up there because there's a 7 after it. So if you look, you can see that pH is equal to 14 minus your pOH on that little road map. So we have 14 minus 2.40. Now you could get your calculator out to do that, or hopefully you can do that in your head, and that should be 11.60. And that's it. That is your answer for sample problem 1. Sample problem 2. We need to figure out what the concentration of hydrogen ions and hydroxide ions are in a healthy person's blood that has a pH of 7.4. We're going to assume that the temperature is 298 Kelvin. Okay? So the easiest thing to do is to go from pH to the concentration of H+. If you look on that map, you can see that the concentration of hydrogen ions or hydronium ions, we can use that interchangeably, should be equal to 10 to the negative of our pH. So what we're going to do, we're going to take 10 to the negative 7.4. So we have, and I would just push that second log to get you the power of 10, and then negative 7.4, put that in parentheses, okay, and you get 3.98 times 10 to the negative 8. Now what I'm seeing on my calculator is actually a big long digit, and then E negative 8. As a reminder, that capital E says, hey, take this number that's in front of it, times 10 to the power of whatever is behind the E. So that's what it ends up being, and that needs a label of molar, okay? So that's the concentration of hydrogen ions. Now we want to find hydroxide ions, okay? But we can do that because now we know our hydrogen ion concentration. So if you look at that little chart, it tells you that if you take 1 times 10 to the negative 14th and divide it by your hydrogen ion concentration, that should give you your hydroxide ion concentration. So what we're going to have is 1 E negative 14, typing it into your calculator, divided by that 3.98 Sorry, I want to put this in like you would put it in your calculator. E negative 8. Okay, so 1 E negative 14 divided by 3.98 E negative 8. Once again, second comma on a TI or any Texas Instrument calculator should get you there. Make sure you use a negative sign and not a minus sign, because me typing it in, I used a minus sign and then it gave me a syntax error. So we have 2.51 times 10 to the negative 7. And once again, I'm actually going to rewrite that because holy horrendous. Negative 7. Once again, since this is a concentration, that's going to be in molar. so moles per liter, or big old capital M, and you're good to go. Okay, done with sample problem 2. Now I do believe we have one last one to work through. Okay, calculate the pH of a 0 or a 0.05 molar HNO3 solution. So if you remember, HNO3, or nitric acid, is a strong acid. That means that the concentration of H plus should be equal to the concentration of the acid itself, because it's going to dissociate completely. So it's going to completely split into H plus and so hydrogen and nitrate ions. So that means our H plus concentration is equal to 0.050 molar. pH is going to be equal to the negative log of that. So we take my calculator picked the perfect time to die. So let's see if I have a second calculator, hopefully. Negative log of 0.5. Okay, 1.30. That's a pretty acidic solution there. Okay. That, yep, is it for today. So you should have a pH calculation worksheet. As always, you can check your work up front with the key. And if you have questions, make sure to use the links that I've provided just for extra instructional videos. Thank you.